So, on today's lesson we'll be learning about set theories. The set theory is simply the theory about set, as the name suggests itself. For example, if we have set, let's call it A, and in this set there will be like numbers like 1, 3, 4, 6, and let there be another set where there will be 2, 4, 6, 7. So in this first part we will learn about intersection. Now the question may be asked, what is the intersection of set A and set B? The answer will simply be A intersection with B is equal to here 4 and 6. Now from here you may understand that in intersection we take the common out of the set we have, such as 4 is common on A and B and 6 is common, while the rest like 1, 3 and 2, 7 are not the common. So we take out this and we write it here. So that is the first thing that we'll be learning on set theory. Next up we have, this is same as the intersection, this is still the intersection, but we'll be introducing a newer symbol. So let's have like K, set K is equal to 3, 4, 8, 9, and let there be set, let it be I, where there will be 7, 6, okay, wait, let's not write it like that, 7, oh no, let's make it like this, 2, 5, 7, sorry, 6, 7. Now what is the intersection in here? In this case we have no intersection somehow, as there are no commons, such as 3 is not in set I and 2 is not in set I, and vice versa with all the numbers. So here we can write this, the Greek letter phi. Whenever there are no commons or no intersection in this set, in any given set, we will have to write phi in it. Okay, next up we have, okay, next up we have union. So let's take set B, which will have 4, 5, 6, 7, and set C, which will have 5, 6, 8, 9. Now in here, what will be the union of B and C? So first of all, in union we simply just combine this true set. Let me first write it down. 4, 5, 6, 7, 8, 9. So in union we just write it like that. However, if you see it properly, we have 5 2 times and 6 2 times. You must remember that we should not write it 2 times in our union, and we should write it only 1 time like here. Alright, moving ahead, we have okay. Alright. Okay. We have the Venn diagram. In this Venn diagram, we have true circles, and it's stating that these two are set. This is set A, and this is set B. And in set A, there are numbers like 3, 4, 5, 8. And in set B, there are numbers 2, 4. Oh, wait. 2, 4, 6, 8. Now, the question asks that find the intersection in this true circle. So, how will we do that? So, in solution, we will first have to make another circle, but this time we will join it together. So, this is the circle A, this is the circle B. Let's write it like this, circle A, B. Now, the middle part where they meet and combine together, we'll call this the intersection of A and B. We'll write it simply like that. Now, from here, we can write like this. So, what are the common? 3 is not common, 4 is common, and 8 is common. And what are not common? 3 and 5 and 2 and 6 are not common. So, in this circle, this new circle, we'll write the intersecting part or intersecting elements in the middle, right here. Let me shade that part right here. So the common or intersecting parts are 4 and 8, so we'll write in here, and we also write it in here too. And next up, we have the uncommon or non-intersecting elements. So in A we have 3 and 5 left out, and in B we have 2 and 6 left out. So that will be the answer for this. Let's move ahead. Next up, we have cardinal numbers. So, for example, if we have set E has 1, 2, 3, and set F has element 3, 4, 5, 6. So, how many elements are in set E? Let's write it like this: number of elements in set E. That will be 1, 2, 3. 3. And next we have set F. In set F, number of elements in set F, which will be 1, 2, 3, 4, 4. So from here we see that in set E there are 3 elements, and in set F there are 4 elements. Now we'll get to the point. What are cardinal numbers? Simply, cardinal numbers are the number of elements in the set. So, if the question is asked, what is the cardinal number of set E? So, first of all, the cardinal number is shown or represented as n and the set. This is the cardinal number and this is the number of elements, so we'll write 3, and this cardinal number of f will be 4. So that's the cardinal number. It's simply the amount or the value of the elements. Let's move ahead. Next up, we have the set builder notation. In set builder notation, we are, oh boy, what is set builder notation? Okay, and roster notation. Let's write that down. Roster notation. So let's make a question on ourselves. Question: write the set of even numbers that is less than, let's make it 10. In roster notation, and in set notation, so how will we represent that? Please look at the question carefully first, and now we'll do this. I was not expecting myself to just make up question in this lesson or in this video, to be honest. Anyway, so what are even numbers? 2, 3, 4, 5, 6. I mean 2, 3. Oh my god. Sorry. sorry. Okay, let me use E to represent even number, and in this set we'll write 2, 4, 6, 8. And okay, that's all, because it said less than 10, so we'll just write this. This is the roster notation. It's just writing down this set. Roster notation is simply writing down this set. Alright, next up we have the set notation. In this case, we have this set, finally this. We finally have this, so we can, in set notation, we can finally write it as E is equal to x be the number, such as x is element of even numbers. Okay, and here we can write as 1 is less than or equal to x. No, not 1. 2 is less than or equal to x, and x is equal to less than or equal to 8. Alright, This is the set notation. I hope that's clear now. Now moving ahead, we have the, let's conclude everything. So we have to first conclude our symbols. First of all, we have intersection. Intersection, which will be like the upside down U, and union, which will be U, and third we have, oh wait, okay, how will I say this, phi. This will be to represent any set where there are no intersection or any common. And next up we have the Venn diagram. Oh boy, oh boy, Venn diagram. And you must also remember that Venn diagram also comes in a lot of ways somehow. Not that a lot, only two. There will be like 2 circles given, or there can be also given 3 circles at one time. Next up we have cardinal numbers. Which will simply be n to any set. Let's just say A. And there is also the such as, which will be simply a long line. And there we have just concluded our symbols, and with it we are finished with our lesson.